everybody, welcome back. We are going to be continuing our discussion about functions, lines, and graphing them today by continuing and discussing parallel and perpendicular lines. This is a super important topic and has plenty of practical applications. So let's dive in. We have three possibilities with lines, and when I say possibilities, I mean different ways that lines can intersect. Two different lines specifically. So this basically means, let me get a pen, means two lines intersecting. That's what we're talking about. Intersecting. Great. First one. The two lines are actually just the same graph. This seems kind of stupid and obvious right now, but you'll see later on that it's not always super obvious. Number two. This is the most common one, that the two different lines intersect at exactly one point. And three, the third one, is that the two lines are parallel lines. Well, let's dive in. What are parallel lines? Oh, look, that's our next definition. Parallel lines. Parallel lines are two non-vertical, we say non-vertical because then it is a function. So two non-vertical lines with the same slope and different y-intercepts. Well, the definition of a parallel line also should include the fact that two parallel lines will never intersect. If two lines are running exactly parallel to each other, that means they have the same slope and will continue having this same slope forever and ever and ever, and will stay equidistant from each other forever and ever and ever. Hence, they will never meet up. So here, back at the possibility of a line, if they are parallel, they have zero intersections. They will never meet. So, okay, let's look at this example. We have two graphs. Y equals 1/2 x plus 4, and then we have y equals 1/2 x plus 2. Does this fit the definition of a parallel line? Well, yes. They both have the same slope, and they both have a different y-intercept, a different b. Here it is, and they're staying equidistant apart the entire time, hence never meeting. That's why they are parallel. Let's look at some examples of parallel lines over here. Here we're going to say, are these parallel or not? Yes or no? Number one, parallel or not? Well, although it may seem that way, the two slopes are different. This is a negative, this is a positive. So no, this is not parallel. It will eventually meet. Two, well, it looks like we're going to have to break down this equation to get it into y equals mx plus b slope-intercept form. So let's bring the 3x over. So now we have 2y equals negative 3x plus 4. Y equals negative 3/2 x plus 2. Our second equation. Divide each side by 4. Divide each side by 4. Y equals negative 3/2 x plus 2. Oh, look at that. They have both the same slopes, but they also have the same b, the same y-intercept. So remember what I said earlier about this number 2 example? The number 1 example, where they are the same graph, and you wouldn't be able to tell? Originally, these two equations look vastly different. They look like different equations, but when you break them down, they are actually the same equation, hence they have the same graph. These are not parallel because they are the same graph, which means in mathematical terms, they have infinitely many solutions. We say a solution is the point at which two functions will intersect. Now, if we look over here and apply this new vocabulary, then we say that the same graph has infinitely many solutions, meaning that every single point on both of these graphs are a solution because every single point is the same as the other equation since they are the same equations. And it's not just whole numbers, negative 1, 1, negative 2, 0 on a graph. They mean broken down to infinitely many decimal places, hence infinitely many solutions. Now, intersect at one point means one solution. And then over here means zero intersections or zero solutions. So here's a new vocabulary word as well, solutions. Great. That was number 2. Okay, so now we're over here. Number 3. Is this graph the same? Well, let's look. Does this go up 2 and over 1? So m equals 2 for this guy. Now over here, we go up 2 and over 1 as well. M also equals 2, and if we trace this, his y-intercept is going to be way down here, while his is all the way over here. So yes, these are indeed parallel. Different y-intercepts, same slope. Fantastic. Let us keep going to number 4. Great, we're going to have to manipulate b's again. So 4y is equal to, let's bring the 6x and the 8 over. So minus 6x minus 8, on the other side, minus 6x minus 8. 4y equals negative 6x minus 8. Great, divide each side by 4, divide by 4. Y equals negative 3 halves x plus 2. Fantastic. Okay, now we're going to have to bring the 4x and the 8 over, plus 4x plus 8. 6y equals 4x plus 8 divided by 6 divided by 6. Y equals 2/3 x plus 8 over 6 is 2/4. So are these the same? Well, their slopes are indeed different, and so are their x-intercepts. So this is, no, it is not parallel. But I chose this question deliberately. Just like we said with this question, you can't really tell if they're the same lines at first, even though these equations look vastly different. These equations look quite similar. I mean, look, they even have the same coefficients used over and over again and the same constant. But they're actually vastly different, and indeed, these are going to be a special kind of lines, which we're going to talk about later on in this lesson, known as perpendicular lines. Perpendicular. Remember, we have the option of parallel, meet at infinitely many points, or no solution, or one solution. And one of the special one solution cases are perpendicular lines. So we'll talk about that next. Number 5. Write an equation of the line that is parallel to the line at y equals 2x plus 1 and goes to the point 2, 7. Well, so this is just like the questions we did in the last lesson, where we had to determine the equation of the line by plugging into x and y. So we know that m is going to have to be 2, because that's part of the rules. It has to have a different b and the same m. So m is going to equal 2. And we have our points. So let's plug in. 7 is equal to 2 times 2, because y is equal to mx plus b. Now we're going to solve for b. 7 is equal to 4 plus b. b is equal to 3. Let us rewrite our equation. Y is equal to 2x plus 3. Here is our answer. This is a different equation from the one we originally had. Thus, they are parallel lines with same slope and different b. Great. Now let's go on to, as I said earlier, perpendicular lines. Perpendicular lines are two lines that meet at a right angle. It's one of the special cases of lines that have one solution, intersect at a single point. Now, what do perpendicular lines entail? Well, we have to learn another vocab word first. A reciprocal. What is a reciprocal? Well, a pair of reciprocals means two numbers that when multiplied by each other will equal 1. For example, 2 and 1/2. Well, 2 has a secret 1, so when you multiply 2 times 1 over 1/2, you're going to get 1. Same with 3/4 and 4/3. If you're looking at a fraction, or even a 2 or a whole number with a secret 1 beneath, the reciprocals of each other are just the same fraction, but flipped upside down. Now, take a second to keep that in your mind and try and really comprehend it. Just like the slopes for parallel lines were the same slopes, the slopes for perpendicular lines are going to be opposite, meaning negative reciprocals. I'll say that again. The slopes for perpendicular lines are going to be negative reciprocals. Now, let's look at this example. Taking a little slow because this is a lot to grasp at first. Here are our two examples of perpendicular lines. Y equals 2x minus 1. Then we have y equals negative 1/2x plus 4. Sorry. That just shows you guys that's my mom. I am also a high school student like you, working on this at home. Let me close that. Working on this at home while my mother is asking me if I've eaten yet. So, yes. Okay, as we're going. Y equals 2x minus 1, and y equals negative 1/2 x plus 4. So the m of this one, m equals 2 over 1. Secret 1 again. Now we have m for this one equals negative 1/2. So these are reciprocals. Well, this and this, excluding the negative. 2 over 1 times 1/2 does indeed equal 1. But one of them has to be negative of the other. And then it doesn't really make a difference for perpendicular lines if their b's are the same or different, because in fact, the point at which they intersect may indeed be their b, which is a-okay. So all you have to worry about is the fact that their slopes are negative reciprocals of each other. So basically, when multiplied by each other, will equal negative 1. Okay, that's a lot, I know, so let's go through it. First one, is this perpendicular or not? Well, their slopes are indeed reciprocals, but they are not negative reciprocals, so this is not. Now, next one, we have to break down these equations again. Remember, divide by 3 on each side. Oh, I'm sorry, what are we doing? We have to bring the 6x over first. My bad, fam. So we're going to go minus 6x on both sides. Remember, Jocelyn, subtract and add before multiplying. What are you doing? 3y equals negative 6x plus 2. Divide by 3, divide by 3. Y equals negative 2x plus 2 thirds. Fantastic. Over here, we're going to bring over the 2x and bring over the 4. Plus 2x minus 4. Both sides, 4y equals 2x minus 4 on both sides. Divide by 4, divide by 4. Y equals 1/2 x minus 1. Fantastic. Now, is this the negative reciprocal of this? Why, indeed it is. 2 and 1/2 are reciprocals, and this one has a negative, while this one has a positive. So yes, this is indeed perpendicular. Let's keep moving. Here is our graph. So now we have to check if the slopes are negative reciprocals of each other. So what is the slope over here? We're going down 2 over 1. So m of blue, m is equal to negative 2. Now what is m of red? This is going up 1 over 2. M is equal to 1/2. Negative 2 and 1/2, if you multiply it by each other, adding in the secret 1, does indeed equal negative 1. Check. This is, yes, it is perpendicular. Also, you can form the little right angle box over here. That is a complete square. Fantastic. Let us keep going. We're going to minus 3x, 6y equals negative 3x plus 4, divided by 6, divided by 6. Y equals negative 1/2 x plus 2 thirds. Cool. Now we're going to have plus 6x plus 2 plus 6x plus 2. 3y is equal to 6x plus 2 divided by 3. Divided by 3. Y equals 2x plus 2 thirds. Here's something funny, guys. Remember how I said, where did it go? How I said over here, back when we were talking about how the b's don't make a difference, that it could very well be the point at which they intersect? Well, this is the case for this question. Look at this. Their slopes are indeed negative reciprocals of each other. Negative 1/2 times 2 over secret 1 does indeed equal negative 1. Check. But their b's are the same. Hence, their solution is going to be at the point 0, 2 thirds. The point at which they intersect is indeed their y-intercepts, thus proving that you don't have to worry about the b's and if they're the same or different when solving for perpendicular lines. Only parallel. Great. Our last one. We're going to write an equation of the line that is perpendicular. Same kind as before. So here is our equation. So we're going to need first an m that is a negative reciprocal. What is the negative reciprocal of 1/2? So we need something that negative 1 is going to equal 1/2 times this new m. What is that going to be? Well, that's going to be, m is going to equal 2. Negative 1 is equal to 1/2, negative 2 equals negative 1/2 times negative 2 over 1. Check. So m is going to equal that. Now we have our point which we're going to plug in. So y is equal to 4 and x is equal to 1. So 4 is equal to negative 2 times 1 plus b. 4 equals negative 2 plus b. b is equal to 6. So what is our equation? Y equals negative 2x plus 6. Ta-da! Here is our new equation. We have our negative reciprocal slopes, and the b's make no difference. There we go. Hope this makes sense. This is a lot to take in at once, so watch the video again, pause it if you have to, do the questions along with me at the same time if it'll help. This is a lot, parallel and perpendicular lines, and then the next chapter we're going to be doing is about actually finding the solutions, finding the points at which these two lines intersect. Thanks, guys. I'll see you next time.